So as you've heard in this morning's keynote, having well-governed and trusted data is more important than ever. In this session, you're going to hear a little bit about the growing partnership between dbt and Tableau, and how together these can help accelerate your governance goals and set you up for success with your AI and BI workloads. Before we get into things, we're just going to introduce ourselves. So I'm Jack. I'm the Director of Consulting and Partnerships for the Information Lab here in the US. I lead a team of principal consultants who work on projects across Tableau, dbt, and Alteryx.
And hi everyone, my name's Harriet Owen. I'm a solutions consultant at the Information Lab. I work with Jack in his team, and I've been helping customers solve problems with their data for the last 4.5 years.
So we're going to kick things off this morning with a little story for you. And the protagonist of our story is Alex here, and she is a director of data analytics. She's just started in a new role at a company called Gaslamp Goods, and she's really excited to get running. She has been promised that she's got complete visibility into her analytics pipeline. There's robust testing so that her team can get ahead of roadblocks before they affect users downstream. There's perfect governance at Gaslamp Goods. That's what she's been told. So they know when they have access to all of the data. They can see who has access. Analysts can get going quickly. And there's trust across all of their metrics. So there's a governed library where her team can go and connect to these. They can start to build out assets, and people trust those metrics. So there's no deliberation over which metric is right. People can just start making decisions quickly with their dashboards. And finally, because of all of this, they're ready to start making use of AI solutions, such as conversational analytics and agent-driven workloads. But I'm seeing some skeptical-looking faces in the audience. Hands up if you think that Alex has been sold a bit of a dream here. Pretty much everyone. So you'd be right. So Alex she's a little bit frustrated. So she's got going, and what she found was that was not really the case at Gaslamp Goods. And me and Harriet had a conversation with her, and she said, I was really excited to start, but the data was such a mess. I couldn't explain to stakeholders why everything was taking so long. And this situation actually really reminds me of something that you found yourself working with recently, Harriet.
Yeah, so some of the client challenges I've faced recently is that the data I was trying to connect to was located in many different places, and sometimes duplicated in those places. So sometimes I was connecting to an Excel sheet, a database, a different data warehouse, and so trying to make sure I was connecting to the right version was quite challenging. This data also had a lack of documentation, and so if I needed to debug an error or trace that data back to the source, it was very time-consuming to do so. And what I've also seen is that clients are growing at a very fast pace, but with very complicated data architectures. And so the data teams, who are supposed to be the experts in using that and enabling everyone else to use that architecture, are no longer able to efficiently use it.
And the scenario that Harriet's talking about, that Alex has found herself in at Gaslamp Goods, we find to be quite common across lots of organizations. So tools like Tableau have been great at creating this dream of self-service analytics, but that dream has also created its own problems. So with the ease that end users can go and connect to data, join tables together, start producing dashboards, this has led to a real lack of rigor around the development of analytics pipelines. So when we start working with organizations, we find in some places there might be lots of custom SQL scripts behind workbooks. Some workbooks might be connected to the output of various workflows. Some might just be connected straight to the data warehouse. And this generally just creates a bit of a mess and a real lack of governance. And so the second challenge that we find is that data is being developed in silos, in lots of different teams, these workflows, these custom SQL scripts. There's a lot of duplication of effort going on, which is slowing down businesses. And we also find that there are inconsistent definitions across the business. So we find that people are deliberating over how metrics should be calculated. In one dashboard, it might be calculated in one way, in another, calculated in another way. And I'm sure people in the audience have been in a situation where they've gone to present a dashboard or some kind of presentation and had people immediately disputing the numbers that are in that dashboard rather than just trying to make decisions. And when those problems arise, it's also really difficult to figure out why something might have gone wrong. There's poor visibility into the data quality issues that might exist within a business. So it's difficult to know whether the data is just stale, whether some kind of transformation has gone wrong upstream, whether data hasn't been loaded in properly. And we know that these issues aren't unique because only 57% of analytics leaders have complete confidence in their data's accuracy. And this is quite a scary stat because that means that nearly half of them don't have complete confidence in their data's accuracy. And these are the analytics leaders, the ones that are developing these products. And so if they don't have complete confidence, then as you move out to the lines of business, it's unlikely that they are going to trust the data that's being created in the business. And it sounds like Alex and her team at Gaslamp Goods are going to fall into this bucket that don't have confidence in the data.
Yeah, so we see a breakdown of confidence across the business. The Chief Data Analytics Officer at Gaslamp Goods reported that executives had nothing but horror stories about working with the data team. Now, I appreciate this is quite a stark quote, but this is the reality for some businesses. The data teams who are supposed to be the experts in that architecture aren't able to efficiently use it. The simple tasks are no longer simple. And from the stakeholders' perspective, their data requests aren't being seen to in a timely manner. And actually, they're questioning the quality of that data that they're reporting off. And so we get stuck in this unproductive loop, and therefore we see trust break down. Now, we know that for a lot of you in the room, you're probably thinking that DBT can help here, and that's exactly what we suggested to Alex when she came to us to help her with some of these challenges.
So as we all know in the room, DBT allows teams to prepare data in a way that is modular, centralized, and governed. But with Alex being brand new to the DBT platform, we needed to explain some of the fundamentals to her. So we explained that DBT takes a software engineering approach to the development of analytics products with modular code and version control, and they call this the analytics development lifecycle. And it allows users to modularize their SQL code, have that peer-reviewed, and create nice, trusted, tested data products. Business logic is centralized in one place in DBT, so business users and developers can use metrics that they trust, and all of these transformations are taking place in the cloud data warehouse of your choice. And finally, we can build in data quality checks in the form of tests in DBT, meaning that if errors arise, downstream processing is stopped, leading to less issues arising in the dashboards that our end users are consuming. And once we'd explained this to Alex, she started to get excited about what DBT could bring to Gaslamp Goods. But with the mess that was around her, she wasn't really sure where she should get started.
So one of the first places that Jack and I started was we wanted to take a look at how they were currently transforming their data. And we came across legacy SQL like this here on the screen. So this is a single script that contains all of the different transformation in one place. Now, what are some of the challenges with a script like this? Well, table references are scattered throughout, making it harder to understand what tables are being used and how they are interconnected. The second thing is there are multiple CTEs at play here, and they're quite complicated CTEs referencing each other. And so if we need to understand what's happening at each step within this script, it's quite challenging to do so. And actually, if a part of this breaks, fixing one part usually breaks another part. And we see SQL like this being used in BI tools like Tableau as custom SQL. And that's where things can get really messy. So we uncovered 4 different Tableau dashboards, all using the same or a similar version of that custom SQL. This is common. As time goes on, we see that business logic changes, and so the version that you want to use of that code might be updated. But the challenge for Alex and her team is that they found that not all of those dashboards were updated, so some of those had been forgotten. You could see how this could easily happen at scale. Your dashboards become their own version of truth, and so when you're using custom SQL like this, you aren't centralizing that SQL code, so that logic gets scattered in the business. And so one of the first things we can do is we can modularize our SQL code in DBT. Now, for a lot of you in the room here today, you're probably familiar with the concept of modularization, but for those that aren't, this is where we take that long SQL script and we break it up into smaller, more manageable chunks. And in DBT, we call these models. We then reference these models within other models. So on the screen here, I have a script, and at the top of that script, I'm referencing 3 other models. So they are staging models that I'm referencing. Now, what are some of the benefits to modularization? Well, the first is this script is a lot more readable. We've taken that long script, and now we're only working with 34 lines of code. The second, each of those models are now reusable. So we've reduced our risk of redundant code and that effort to have to rewrite those pieces of logic. And actually, the final thing with modularization is that it helps in error identification. When something breaks within this transformation process, we can narrow down where that happened within a single model and then easily debug and fix it. The final thing with DBT that I want to mention here is that it's integrated directly with GitHub. And so Alex's engineers can be working on these models simultaneously, facilitating parallel development and actually speeding up that analytics development lifecycle. So Alex was on board with this, but she wanted to know what else DBT could offer her. And that's when Jack and I introduced the idea of creating a semantic layer. But before we get into that, let's talk about the most common setup that people use today. And that is to connect directly to the data warehouse from within your BI layer. This works, it's obviously common, lots of people do it. But analysts and teams then have to rebuild join and calculation logic within all of their downstream tools. So this can lead to inconsistent logic, slower queries, and that all too familiar question, is that value correct? Now, obviously, this is what Alex is trying to avoid. And so when we use a semantic layer, that sits between that data warehouse and our downstream tools, acting as a single and governed translation layer. Within that semantic layer, we define metrics, so things like revenue, customer, churn rate, and we define that in a single place and in terms that everyone in the business understands. And because we're defining that in one place only, it means all of those downstream tools are now working off of the same definitions. And so dashboards are built faster, they align better, and therefore trust goes up. Now, the second thing with a semantic layer that I want to talk about is related to AI. There's obviously an increasing drive for customers to be incorporating conversational and agentic analytics into their data workflows. But the problem with AI tooling is it needs to understand what data means, not just what it contains. And that's where a semantic layer can help. Within that semantic layer, we are defining metrics. And so without that semantic layer, tools like Tableau Next and MCP servers can't interpret and then serve up conversational analytics very well. The second thing is that the answers that AI provide might be misleading or actually just incorrect, and therefore not trusted or adopted. Okay, why don't we get into DBT and have a look at how some of this is set up. So what Jack and I did is we transformed their data for them. We rebuilt that data architecture. And this is what I'm showing you on the screen is the lineage of the data project that we created in DBT. But let's start by taking a look at the left-hand side here. This is that pre-semantic layer setup. Here I have my different source tables. So these reside in Snowflake containing that raw data. And then these are the models within DBT where we translate that raw data ready for analytics. If we start by taking a look at this orders model, when I select this within the lineage, I get some helpful highlighting going on here, as well as some additional information on the right, where I get a description, but I can also see the column breakdown. So what are the columns being used within that one model? What's the description for each of those columns? And what data tests am I running against those columns? We'll get into data tests in a little bit more in a moment, but what I want us to take a look at here is actually what this orders table is being derived from. So with this highlighting action here, I can see that this is being derived from 3 different staging models. Now this is modularization. Instead of incorporating all of this logic in a single script, I've now broken that logic out. One of the benefits that I mentioned to modularization was this idea of reusability, and we can see that here. This staging orders model is actually also being reused downstream in 2 other models. I talked through some benefits of this, but you can think about this as saving Alex's engineers time. They define that logic once and then they reuse that downstream. Not to mention the benefits that come with that for error identification and debugging. So that's our models, but let's take a look at the right-hand side of this lineage. This here is the semantic layer setup. In pink, which is quite small, I appreciate, but they are the semantic models. And then to the right of that are many different metrics in yellow. This order item semantic model is that translation layer that sits on top of the order items model, so that final table. And then on top of that, we then define those metrics. So if we take a look at one of these examples, this revenue growth month over month metric, we can see all of the upstream assets that are used to create that. I also get a description of what this is. So this is looking at the revenue change from one month to the next as a percentage. I can also see that this is a derived metric, so we can define many different types of metrics within dbt. And I also get a preview of what that expression is. So how is this metric being calculated? Now, I mentioned that we get this highlighting going on here. What this means for Alex, this is documentation that she didn't have before. Alex and her engineers get this complete pipeline visibility there of what is being used to derive each of these different resources, which is really, really beneficial. But if you're not familiar with the semantic layer, you're probably thinking, well, what is actually happening in the background here? How do we define these semantic layers? So let's take a look at the order items semantic model. I'm going to go ahead and view this resource and open it in the studio. Now, semantic layers are defined in YAML files. If you aren't familiar with what this is essentially a configuration file. And at the top of this file here, I am defining this to be a semantic model. And I'm saying that this is a semantic model for the order items table that, if you remember in that lineage that I showed you. So this is sitting on top of that order items table. Now, we define many different things within a semantic model. The first is entities. So what are my primary and foreign keys within my order items table? This data set is at the order item level, so grain. So that is the unique primary key to this data set. And then I've got order ID and product ID as the foreign keys that I'm going to use to join to other semantic models. If we carry on down, we get to defining dimensions. So what are my categorical fields within the order items table? And then we get to defining measures. And the one that I want to walk through is this revenue measure here. We can add descriptions to these measures. You can see the field that I'm actually building this off of. So the product price column from the order items table is going to be defined as revenue in my semantic layer. I can also define the aggregation of this measure. So this is one of the key things that we're doing here. We are setting the aggregation of our measures within the semantic layer. So now what this means when I use revenue downstream in any of my reporting tools, it's always going to be at the sum level. If I was creating average revenue, then I would have set the aggregation to be average. And then I have this create metric flag. So I'm also saying, please treat this revenue measure as a metric as well. And so the second thing and the final thing that I define within this file here, this YAML file, is metrics. So the metrics are using those measures. And let's take a look at one example here. let's look at that revenue growth month over month that I just introduced. Now, there is this expression parameter. That is the calculation that we're going to use to define and calculate the revenue growth month over month. Now, for Alex and her team, they use this really frequently in all of their downstream dashboards in Tableau. And they had noticed that this was actually being calculated incorrectly sometimes. So the benefit of this, and you can think about this happening at scale as well, when you've got many metrics, all with quite complicated business logic, being defined in one place only, then it's easy when you're using those metrics within the dashboards, within your downstream layer. Not sure what's happening to that screen, but hopefully you're still following. So this is quite a long file. There's a lot to define here to manually type out. And so we're going to use dbt Copilot now live to build a semantic layer for our customers table. This customers table looks at the customer ID grain, and it's providing information like the number of orders purchased per customer, as well as their lifetime spend. And so let's go ahead and create that semantic layer. I simply just select dbt Copilot and then select semantic model. What this is doing in the background, it's going to try and identify those entities, dimensions, measures, and then metrics. So let me zoom in slightly. We've got a description, so it's tried to find and work out what would be an appropriate description for the customers table. It's managed to identify the customer ID as that primary key of the data set. Things like dates, it's identified that at the day granularity within our dimensions. And then if we look at one example of our measures, the orders per customer has been identified as a measure. It's been identified as a sum, so it should be aggregated as a sum. And then we've also got this create metric true. So we're also going to have this as a metric within our downstream tools. Now, you can use this as a template and build on it further or as is, but this is really helpful, saving your engineers some time rather than writing this out manually. Now, the other thing that we can define in YAML files is data tests. So I'm going to show you now a customer's YAML file. So this YAML file is specific to the customer's model, that final table. Within this, I have got a description for the table, as well as descriptions for all of the different columns within that table. So we think about earlier when we were talking about AI being able to interpret this data correctly, all of these descriptions there are going to be really valuable. And then we have our data tests. So for each column within our data set there, we are adding tests. So I'm going to keep quite a simple example here, and that is for the customer ID. We obviously want this to be unique. This is the primary key of the data set. And I also don't want this to ever be null. So these tests are going to be running every time I build these models, ensuring that when we are using this semantic layer, which are built off of these models, this data is accurate and valid. Okay, so I've showed you quite a lot there. We transformed that data, we modularized that code, we then built a semantic layer for Alex. We added documentation along the way, and we ensured that the quality of the data was good and sound by adding those data tests to those columns. And so what we can do now is we can bring this into Tableau. This is the Tableau interface for anyone that isn't familiar, but at the top here, I am connecting directly to that semantic layer. So Tableau has a connector to directly use dbt semantic layers. At the top here, I'm showing you the different dimensions to that semantic layer, as well as the different metrics down here. But let's walk through one example. So on the screen here, I'm showing you the sum of revenue. So I'm using that revenue measure, a metric that we defined, by month. I told you that Alex frequently reports on revenue growth month over month, and so I'm going to bring into the view now this metric. I'm going to drag and pop that onto label, and what we can see now is we get that growth on top of each bar month over month. I hope no one's having problems with this flashing at you. So what's happened there is I, as the developer in Tableau, I've not had to put in any extra work there. I can simply now drag in and use that logic defined in that semantic layer. So you can think about that saving time, but also that logic is sound. We are happy that that's the right way to calculate that. The last thing that I want to show you here in Tableau is that we don't just have to use that metric as is. We can also splice and dice this with the dimensions in our data set. So I'm going to bring in product type category, and we can see now that that is successfully calculating that month-over-month growth across the two different product type categories there. Okay, so what Jack and I did is we used this entire semantic layer and we built a final dashboard for Alex to use to be able to report on revenue and profit. We're obviously very happy that the logic behind this is correct, is exactly how we want the business to be calculating things. But what about our stakeholders? There have been so many times that I have built Tableau dashboards and I've had my stakeholder ask me, how do I know this value is correct, Harriet? And the final thing that I want to show you today is the DBT health tile. And that is this here. Within this tile, we get two pieces of information. The first is a freshness check. So is my data fresh or stale? What this is showing me is that one of those tables, one of those source tables in Snowflake is fresh, and 5 of them have been delayed in today. So they haven't loaded in time. The second piece of information is a data quality check. So all of those tests that I showed you against those columns, we are seeing the outcome of whether they passed or failed here. And so I'm being told that there is a check, 100% of my tests passed there. So 28 of them passed, and we're actually only looking at about a 63% coverage of tests on that whole project at the moment. So maybe we might want to go away and make sure we've got 100% there. So what this means for your stakeholders is that final check for them that yes, the data that they're looking at is sound logic, but also it's accurate and up to date. So that when they go and make business decisions on this data, they are confident and they can trust it.
So now that Alex is powering Tableau with DBT, look at her. She's thrilled. She's buzzing, like everyone should be. So she's now got her semantic layer in place, what she thought she was going to have to begin with. So she's got one place where her analysts are working from. The metrics are trusted by the business, so they can make decisions faster. Those data health tiles offer widespread visibility into the quality of the data. So stakeholders get a glance at whether data is stale. They don't have to pester the data teams to understand that. And they get a bit of a preview of those tests that Alex's team has set up. But for Alex's team themselves, having those tests allows them to get ahead of issues that might arise in the data and start fixing those before they hit the end users. And finally, with her team using DBT Copilot to develop, they're shipping data products much faster than ever before, just speeding up the efficiency of the business. And so everything that we've shown you here today is available in Tableau right now. So if you are using Tableau Cloud, you can use the DBT semantic layer connector to connect to your semantic layer, whether you have one developed or whether you plan to develop semantic layers. And those health tiles are also readily available for you to set up within your dashboard so you can start communicating the quality of your data to those end users. Now, if this session has got you interested in semantic layers and using those in your DBT projects, we just wanted to call out a couple of other sessions that are taking place at Coalesce around the semantic layers that DBT has to offer. This isn't all of them, so sorry if you're any of these people and we didn't call you out. But Built have a session later this afternoon about how they have set up their semantic layer to LLMs. There is a workshop tomorrow afternoon where you can get hands-on with building semantic layer, which is being hosted by DBT. And then on Thursday, there are 2 sessions, so one by OpenAI and how they're using the semantic layer, and on Thursday, just half an hour after that, there's a session from Sweetgreen. So thank you for listening. We've actually, off the back of this, started playing around with that semantic layer that we created, and a lot of the talk this morning was about MCP servers and what you can do there. So when I say we started doing this recently, we did it like literally yesterday afternoon. So if anyone wants to have a conversation with us around like what that looks like, we can give you a little preview on a laptop, but we'll be sticking around for questions, and thank you for coming to our session.